Hi, in this podcast, we're going to learn how to draw functional groups, which are groups of atoms that always behave in the same way. And using these groups, we can continue working with line and structure drawing that we started with the first podcast. So get ready to draw. Okay, we're going to learn about the functional groups of organic chemistry. It's really good to understand these structures and be able to draw them accurately and precisely. Now, the first ones are the alkanes. I usually don't think of them as functional groups because they really don't have any ability to change into other functional groups except for one reaction that we do. But alkanes, if they aren't in a ring, have the formula CnH2n plus 2. There are no double bonds or triple bonds, and really nothing of interest. So if I draw this structure right here, that's an alkane. If I draw this structure here, that's an alkane. Now, if I draw this structure here, that's also an alkane, but it's not CnH2n plus 2 because it has a ring. But still, because it has no double bonds or no triple bonds, it's an alkane. It's also called a saturated hydrocarbon. Saturated means it has all the H's that it can with no double bonds or no rings. The next ones are the alkenes. Alkenes have one double bond, or it can have two double bonds. But anything with double bonds, C double bond Cs, are alkenes, unless, of course, they're aromatics, but we'll learn about those. So if I have this, or if I have this structure right here, let's put the double bond there, these all with one double bond have the formula CnH2n. So for every one double bond, you lose two H's. And of course, you can have a double bond in a ring. And then if you count up your H's, this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if you look at this formula, this is C6H10. So it has, quote, lost 4 H's, one for the ring and one for the double bond. The next one are the alkynes. Alkynes have at least one triple bond. And as I said before, it's sort of funny how to draw them. Don't draw them like this. That just looks dumb because alkynes have an 180-degree bond. So this just looks silly. So you draw alkynes like this. That's a carbon with 3 H's, and here is your triple bond, and then there is your other one. So alkynes have a 180-degree structure here, so you really have to draw it that way. You can't put an alkyne in a ring, at least not in a 6-membered ring, because there's just not enough room to wrap around and meet up with another alkyne. So if we count up the structure here, this would be 1, 2, 3, 4. This would be C4H, 1, 2, 3. I'll put the dots in. 4, 5, 6. C4H6. Now there's one other functional group that doesn't include any other atom besides carbon and hydrogen. And these are called aromatics. And we'll have a whole session or class on aromatic hydrocarbons. If you have 6 carbons in a row or in a ring and alternating double bonds like this is an aromatic hydrocarbon. This itself is called benzene. It's got a formula C6H6. So this is different than an alkene in that these double bonds behave differently than these double bonds. Okay, now functional groups that include other kinds of atoms are grouped into 2 different groups. The one that are alkyl halides. Now, if you remember from your introductory or AP or Gen Chem class, a halide are the atoms at the end of the periodic table: fluorine, chlorine, bromine, an iodine. So alkyl means it's a carbon group attached to a halide. So this would be an alkyl halide. Or this would be an alkyl halide. We will use these when we get into substitution reactions. Okay, so those are the functional groups that don't include oxygen. And so the next page will be functional groups that do include oxygen. Okay, so functional groups that include oxygen. And there are 6 of them that you need to know. And I always do them in groups of 2. So the first one we've seen before when we did our Lewis structures are alcohols. So if you have an alkyl group, I'm going to draw it like this, attached to an OH. Now, a lot of times an alkyl group, we'll call that R. R just stands for any alkyl group. Alkyl groups are pieces of carbon and hydrogen. So R is the universal stand-in for alkyl groups. So this is an alcohol. You can draw an alcohol in a straight chain. You can draw an alcohol in a ring chain. These are all alcohols. So the structure is, now remember, you always draw the H on the O. Don't just go like this and go draw it like that. That looks funny. It looks like that's a minus. You never know if it's an H or not. So always make sure you attach an H to the O. You can draw it like this or draw it like this. The next one are the ethers. Ethers have the alkyl groups on either side of the oxygen. So I could draw this R, O, R. Put a prime because those R's could be the same or different. So an ether would look like that, or an ether could be in a ring like that. So those are the ethers. The next we have are aldehydes. The next 4 functional groups all have C double bond O's in them. So an aldehyde is a C double bond O attached to an H, and then it's attached to another alkyl group. Or it could be attached to an H. So aldehydes have to be at the end of a chain. Because if you look, this carbon already has 3 bonds, so it has to be attached to something else. So you could have it like that, or you could draw it attached to a ring like this. So that's an aldehyde. The one that I always do with aldehydes is a ketone. Ketones have the C double bond O sandwiched between 2 alkyl groups. So this would be a ketone, and this would be a ketone. So ketones are in the middle. The next one is the carboxylic acid. And like aldehydes, they have to go at the end. So now you have a C double bond O attached to an OH. And then it's attached to an alkyl group. So this would be the structure of a carboxylic acid. You should be familiar with this carboxylic acid, that is acetic acid or vinegar. And the last 2, following the same theme, oh, shoot, not the last 2. The last one is an ester. An ester is like a ketone in that it's in between. So you have a C double bond O attached to an O, which is attached to an alkyl group. And so this structure right here is an ester. This is actually fingernail polish remover. It's called ethyl acetate, or you could have an ester that looks like this. You can do all sorts of different things with the different R groups. So those are the functional groups. And the next one we're going to learn about is resonance and formal charges.